Hello everyone, Namaskar, Raj Krishna this side, and let's solve one more problem from linear differential equation with constant coefficient. We have this problem in front of us. Solve d power 4 minus 2d cube plus d square operating on y equals to x cube. So let's start off with this. As you know, the first step will be to find the complementary function. Followed by that, we'll find the particular integral. So for complementary function, we need the auxiliary equation. So let's find that. Just replace this d by m. So m power 4 minus 2m cube plus m square, equate it to 0. Now I can find this roots one by one by using synthetic division method. But sometimes factorization may work for us. So let's see in this case. As I can see, at least two powers of m is there in each of the terms. So if I take m square common, I'll get m square minus 2m plus 1. This equals to 0. Now inside what I am having is nothing but m minus 1 whole square. So if I equate each of them to 0, so if I equate m square to 0, I am going to get two roots, 0 and 0. And in case I equate m minus 1 whole square to 0, I can also write this as like this. So again I am getting two repeated roots, 1 and 1. So four roots which I am getting are m1 as 0, m2 is 0, m3 is 1 and m4 is 1. So in case repeated root, how you write your complementary function? C1 plus C2, because only two are repeating. So with second you will multiply x, and with that you will multiply e power mx. So what is repeating? 0 is repeating, so e power 0x plus C3 plus with C4 you have to multiply x because it is repeating, and e power 1x. So if I write it better way, I can write this as C1 plus C2x plus C3 plus C4x being multiplied by e power x. So this is what I have got as my complementary function. Now I will proceed to solve my particular integral. So my particular integral will be nothing but 1 upon d power 4 minus 2d cube plus d square operating on x cube, I guess. So whenever you have x power n, then how to find the particular integral? In that case, what we do, we try to take the highest power from denominator out. So highest power in this case is highest power or the lowest power? The lowest power, okay. So lowest power if you take out, so d square will come out. What are you left inside is, if I write d square place first, so 1 from there, and I will get d square minus 2d as the other term. So I took out the lowest power out and I am left with this. Why I took the lowest power out? So that I get a 1 here. And now in the next step you will realize something. This is operating on x cube. So on the next step, as I can see, is This you have got as 1 upon d square with you, and 1 plus d square minus 2d. Our first target will be to solve for this bracket. 1 upon d square will treat it later on. So let it as it is in the next few steps. Now this 1 plus d square minus 2d, if it goes up, it can be written as 1 plus d square minus 2d power minus 1. And this is operating on x cube. Now 1 plus x power minus 1 is 1 minus x plus x square minus x cube plus x power 4 minus x power 5 and so on. So I will have to see up to how many terms I will have to open this, okay? Because you see d square is appearing, minus 2d is appearing. So I will have to check the derivatives of x cube. So the first derivative of x cube, which is simply d of x cube, is, you all know, 3x square. Second derivative if I need, so I will differentiate 3x square again. So if you differentiate 3x square again, it will be 6x. I am writing in short way. Third derivative, again differentiate 6x, so you will get 6. Fourth derivative, again differentiate 6, you are going to get 0. And all the higher derivatives. So if I say d power k of x cube equals to 0, where k is 4, 5, 6 and so on. So all the higher derivatives starting from the fourth derivative are going to give us 0. So we are going to open this only till power 3. Okay. So let's proceed. So our pi is our pi is 1 upon d square. And now we'll open. So 1 minus, now x, in place of x I have d square minus 2d. So 1 minus x plus x square. So plus d square minus 2d whole square. So that will give you d power 4 minus 4d cube plus 4d square. So you have got 1 minus x plus x square. One more term is there, x cube. Okay. So if I say for x cube, so it will be d square d2 minus 2d whole cube. So a cube minus b cube minus 3ab. All negative will be there. So with minus it will come. So a cube minus of b cube. Okay. So minus of b cube. So d cube from here, minus 8 from here, and 1 minus is there. So plus of 8d cube minus 3ab. So minus 3ab. So that will become plus 6d cube and a minus b. This is what we have done, and this entire thing is operating on x cube, and Not to neglect, more terms are there, but we are not writing. Entire thing is operating on x cube. So my particular integral is 1 upon d square 1. Okay, I have already calculated the derivatives for the sake of simplicity. And you know the derivative also, you can do that anytime. So this 1 will be multiplied by x cube, that will give you x cube. D square, that means second derivative. So second derivative of x cube is 3x square or 6x. Okay, first derivative is 3x square, second derivative is 6x. So you'll get minus 6x here. Again, minus minus plus. So 2 times d. D means first derivative. So 2 times 3x square. So 6x. So, sorry. Yes, 6x square. Again, d power 4. Fourth derivative, it was 0. Third derivative. Third derivative came out to be 6. So, minus third derivative is 6 multiplied by minus 4. So, minus 24. Second, d2. That means second derivative. Second derivative, first derivative 3x squared, second derivative 6x. 6x multiplied by 4. Okay, wait. Second derivative they are asking. 6x multiplied by 4, 24x. Now 6 derivative again 0. Third derivative 6. And that 6 multiplied by 8. That is 48 and a minus sign. Again, d cube into d square, d power 5, neglect that. That is the fifth derivative. If you wish, you can write minus of 0 there. D cube into d, again fourth derivative, neglect that. If you wish, you can write 0 there. Now, let's calculate it further. So, your particular integral is 1 upon d square. X cube term is there. 24 minus 6 is 18. Plus 6x square. And this is 24 into 3, minus of 72. Fine. Now you have 1 upon d square. So I can write this as 1 upon d, and 1 upon d I am taking inside. Fine. 1 upon d is same as integration with respect to x. So 1 upon d. Integration of this is x power 4 by 4. Again, if you integrate 18x, you will get 18x square by 2. 9x square it will give you. Then 6 x cube by 3, that means 2x cube. And minus 72 times x. Again, you have to integrate it one more time. So if you integrate x power 4 by 4, 1 by d is same as integration. So you are integrating basically this whole expression. So you'll get x power 5 divided by 4 into 5 is 20, because 1 5 will come because of integration. 4 was already there, 4 into 5 is 20. 9 is there, 9x square is there. If you integrate x square, you will get x cube by 3. So that will clear out this 1 3. I'm just skipping step. I hope that much you can calculate in mind till now. So x cube by 3, 3 and 9 got cancelled and I'm left with this. Now again x power 4 by 4. So I'm getting, because this 2 got cancelled with the 4 in denominator. And x square by 2, so minus 36 x square. This is what I have got till now. So everything looks fine, but this 36x square is not matching, so I will have to look back from where I got 36x square. Okay, so that 8d cube term, so a cube, so d square cube was d power 6 minus b cube, b was 2d. Okay, there I made the mistake, it should be minus 8d cube. So I will have to correct that. So there it will be minus 8d cube, and followed by that it will become plus 8d cube. So third derivative is 6. So here minus 48 term will go. This will become plus 48, and plus 48 minus 24 is here 24 positive. So this becomes incorrect. And now this also I have to remove, this also I have to remove. Now let's see. So it will be minus 8d cube. So minus 8d cube plus 8d cube. Third derivative is 6. 6 into 8 is 48. 48 minus 24 is 24. Now 24, if you integrate, so you will get 24x. So you will get 24 x square by 2. So 12x square. Now if I check with my calculations, so x power 5 by 20 plus x power 4 by 2, 3x cube and 12x square. Particular integral is fine enough. Now as we have already calculated the complementary function, time to write the final solution. Y equals to CF plus PI. So y equals to, what was our CF? It was C1 plus C2x plus e power x C3 plus C4x, because first two repeated were 0 and the next two repeated were 1, and plus the pi which you have calculated now. So it will be, if I write in increasing power of x, so 12x square, 3x cube, so this is your final answer to be written. So at one place I made some mistake just in writing the terms, because it should be 2d whole cube, a cube minus b cube minus 3ab a minus b. Okay, I'm not have to take sign when applying the formula. So that's it from my side. I hope you understood something from this video. For more such videos on this topic, you can visit the playlist Ordinary Differential Equation. Thanks again.